In this video, we're going to be analyzing different Java codes and figuring out the big O of the entire Java code by combining these different methods. So we have public void insert all. Here, node root null, root equals insert root x. Here we have one for inserting. This is insert all, and then this is in order. So we're asked, what is the overall time complexity? How do we figure this out? So we have to figure out what our insert complexity is. When you insert into a balanced BST, that's going to be O log of n. And why is that? Because in a balanced BST, your height is going to equal to log n. So then if you are going to loop, if you're going to loop over n times, that means that your insertion cost is going to be n times log n. And you can just say on log of n. Now let's look at our in-order traversal. Here, when you have in-order traversal, you visit each node exactly once. So that's going to be O of n. Now let's combine the costs. So you're going to have O n log n plus O of n. So this is your dominant one. So that's going to be overall. So your answer is going to be O n log n. Now let's say we have this public void build tree and public void level order. So here, we're going to ask what's the overall time complexity and how do we figure this out? So here, we have a skewed BST that's being created. And in order to find the height of this, it's just going to equal to the n number of nodes you have. So that means that your insert cost is going to still be O of n, like it is always, because you, or no, not like before, because before your insert was h equals log n, because that was your height. But here your height is n, not log of n. So your insert's going to be greater because you may have to traverse your entire tree. Now, what about n inserts? So if you have a number of inserts times n, your height, that's going to equal to n squared. So you have O of n squared. Now let's combine these two. You have O of n squared plus O of n. So you have this O of n. You have your O of n squared here from your inserts. Now which one's the dominant one? This is your dominant one. Therefore, your overall time complexity is going to be O of n squared. Assume the tree remains balanced. What is the time complexity? So how do we figure this out? Again, we're going to look at the number of inserts. So here, you only have 5 inserts. So that's going to be constant. It's going to be a constant number. So that means your cost for insert is O of 1. And we have a pre-order traversal. So when you have pre-order and when you have traversal, it's going to visit every node in the tree. So if your tree has n nodes, the cost is going to be O of n. Now, if you combine this, you have O of 1 plus your O of n. And your O of n here. So now, which one is the dominant one? Your dominant one is O of n. So your final complexity is going to be O of n. Now let's look at this. We have public void build and print int array. public root is equal to null. We're going to have this loop here and insert. So we're going to assume that the BST is balanced. We want the overall. So when it's balanced, your height is going to be what? So when you have a balanced BST insert, we know that insert is going to be O log of n because your height is going to be log of n. And we know that here you have in order traversal. When you have in order, it visits every node. So it's dependent on how many nodes you have, O of n. So just combine that. So here we have the insertion is O log of n, right? But here we have that the loop, it runs n times. So that's O of n. So that means for your insertion, you're going to have to consider both of these. You're going to have O n log n. Now, what about when you have an in-order traversal, which is what we said here? That's O of n, right? And what about your pre-order traversal? That's going to be O of n. Pre-order, it visits every node as well. So O of n. Now let's combine these all. So you're going to have O n log n, and you're going to have plus O of n plus O of n. So your dominant term is this, therefore that's going to be your answer C. Now let's just summarize all of the operation times we have. Operation time complexity. So let's list our operations. So for operations we have insert, insert, you have search, you have traversal, and you have build tree with n inserts. It's going to be different depending on if you have a balanced BST, where your height is equal to log n, and when you have a worst BST, where your height is equal to O of n. Now, what are these going to be? When you have insert, it's going to be O log of n, O log of n, O of n, and O n log of n. In worst case, they're all going to be O of n. And this is going to be O of n squared.